Hello everyone, and a very warm welcome. My name is Peter Willmott, and I'm going to be joined. The description of our workshop is as shown there. It's a wastewater utility sewage treatment workshop to deliver asset optimization performance using the TPM system of work by working in partnership with both the asset owner and the operations and maintenance teams. The style of the workshop has been designed as two separate but sequential 60-minute learning sessions. The first one today, part one, and part two is tomorrow at 12:15 to 13:15, stressing it is designed as two sequential ones. So please, hopefully you can attend both. And what Andy and I will share with you is how you can drive and sustain business change, deliver operational excellence, and most importantly, create a company culture that supports and sustains improvement through delivery of an effective and sustainable partnership. And central to our delivery, we'll be sharing experiences based on two case studies, one of which is working with a major UK-based water utility using TPM principles applied to two of their largest sewage treatment plants. The other is a wastewater utility who are just starting out on their journey, who happen to be based on the American continent. Hello, everyone.
The origins and history of Total Productive Maintenance, TPM. Total Productive Maintenance, TPM, and the story behind its creation has developed in parallel with the drive of modern industrial society's need to adjust to increasingly complex levels of technology and automation. In order to fully grasp TPM's powerful application of what is often generically called operational excellence in the workplace, it's helpful to have an understanding of its origins. Here are some of these significant timeline headlines. TPM was developed in Japan in the turbulent years after World War II. In their determination to re-establish themselves as an economic industrial force, Japan faced a number of challenges, one of which was that if they wanted to make efficient use of rapidly emerging mass production techniques and automation, then those physical assets would only be as good as their ability to maintain them in good working order, and would therefore need to be based on preventative and predictive maintenance techniques rather than simply run to failure. It is at this point that the early seed was sown that the operator of these physical assets had a key role to play in becoming an essential part of the early warning system for the maintainer colleagues. This correct belief was based on the fact that the operator, without the need for the spanner and the screwdriver, would carry out routine daily checks and visual inspection of the condition of their now jointly owned assets, because they are in the best position to spot early signs of deterioration. This essential requirement for physical asset reliability had also been brought up into sharp focus when notoriaries like Dr. Deming of the USA toured Japan in the 1950s and the 1960s and presented the concepts of TQM, Total Quality Management, with a focus on customer-driven, consistent, high-quality product. In the 1960s, Nippon Denso, a major supplier to Toyota Automotive Company, was an early adopter of TPM as a key pillar of what became the world-recognized Toyota Production System, TPS. Key influences in bringing about this clarity of thought and purpose included Dr. Seigo Shingo. Their combined efforts, together with a growing number of similar industrial enterprises, were also assisted by the emergence in 1971 of the Japan Institute of Planned Maintenance, with such luminaries as Nakajima and Suzuki, developing the JIPM benchmarking, standardization and accreditation services based on TPM's 5 original founding principles, which we will explain here in some detail later on. I'd now like to hand you over to my colleague, Peter Willmott, to share his personal experience story with you, which will serve to illustrate.
Whilst I was heading up a TPM study tour to Japan in 1992, we visited a company called Daikan Industries, a recognized world-class manufacturer of air conditioning units, an exemplar Japan Institute of Plant Maintenance TPM award-winning company. As we entered the plant on our tour bus, we saw that the outside factory wall had been painted with a colourful montage of trees, bushes, flowers and plants, with a message written in both Japanese and English, which simply stated, "Welcome to our park within a factory." Not, you will note, a factory within a park. So we, dare I say, slightly sceptical European bastions of industry, went on a tour of the factory. The visual impact was indeed memorable from 3 perspectives. First of all, there were dedicated rest areas in several parts of the plant that had natural wooden seating, natural grass, running water with mini waterfalls, flowers, and of course, yucca plants galore. There were also large transparent windows in the roof to enhance a feeling of space and light. And finally, everyone appeared to be working harmoniously rather than fast. After the factory tour, the TPM's facilitator and a small group of operators and maintainers gave a short presentation feedback in the debriefing room, which highlighted the following metrics of what TPM had helped to deliver to the business over a 6-year period. Monthly breakdowns down from 250 a month to just over 5 a month over the 6-year period. Site-wide overall equipment effectiveness was up from 65% to 88%, a productivity increase of 80% over those 6 years, and a per dollar payback of a ratio of $1 to $4.50. Very impressive by any standards. Immediately after the team presentation, I vividly remember the Japanese managing director then walking up to a flip chart and progressively writing. In the 50s and 60s, we had M for manufacturing. Then in the 70s, we had IM for integrated manufacturing. And then in the 80s, we had computer integrated manufacturing. He paused for a moment and then said, "For the remainder of this decade and 2000 and beyond, our company is going to be pursuing CHIM, Computer Human Integrated Manufacturing." He added, "As you have witnessed today, we've decided to reintroduce the human being back into the workplace." As illustrated here, CHIM is no dream, it's a pressing reality. Today, nearly 30 years later, my interpretation of that powerful message is that it certainly represents a challenge for all of us to develop and harness people's skills in parallel with advancing automation, data capture, and technological innovation in what's being referred to as the 4th Industrial Revolution or Industry 4. The bottom line is that it's our people at the sharp end of the business who will continue to make a difference. The biggest and often false assumption nowadays is that regular visible and physical human inspections and maintenance are grossly undervalued, and you could say that the technological tail is in effect left wagging the dog. The tail's an important part of the dog, but in this analogy, the dog is a human being. As such, we also need to remember our heritage in the sense of maintenance engineering development and where we've come from over those last 60 years. In the 60s and 70s, we moved from single-skilled to multi-skilled in the 80s and 90s. Today, as in Halton Region, we have flexible teams who are responsive and adaptive as circumstances present themselves. What we're going to need from now onwards to take full advantage of Industry 4 is resourceful, all-purpose teams of operators and maintainers, together with their supervisors who are involved in the decisions and are autonomous within clear boundaries and rules, which they themselves had helped to set through the proactive support of the utility-wide leadership team that's committed to a consistent and clear, visible leadership style that in effect trusts to delegate. And that's precisely what TPM sets out to deliver those attributes. Whilst embracing technology, there will always be some principles of work and values that will remain embedded within the philosophy of TPM. Of course, we'll need to be agile, flexible, and innovative on how we adapt to the challenges that Industry 4 will bring. And indeed is already doing so in terms of, for example, the Internet of Things, big data and advanced analytics, remote condition monitoring, artificial intelligence, robotics and automation, and so on. Against this backdrop of reality and acceptance, I'm also personally convinced that true and lasting enhanced quality of life in the workplace will come from those enterprises who focus on a selective but well-judged and hence smart application of available automation and technology. Already, we're seeing that the fundamental and underpinning people engagement practices through teamwork, goal alignment, and deployment depends on the leadership style that's able to progressively trust to delegate. This factor will become even more important as technology becomes even more multifaceted. There's also a key message to remember is that the achievement of operational excellence will remain just an aspiration unless we have these 6 operational basics in place, as shown here as part of our foundations, as in standard and safe operating procedures, best practice workplace organization, basic process optimization and control, a disciplined, self-determined TPM asset care regime, reliable data collection and interpretation, and of course, continuous training and development of our people. So in spite of these rapidly emerging technologies, it's also our firm belief that value-adding maintenance in the sense of using spanners and screwdrivers will be here for some while yet.
The origins and history of total productive Halton Region developed this blueprint maintenance strategy based on its site strategic objectives and recognized asset management principles with its 3 themes described here as 1, good practice, 2, 0 unplanned stops, and 3, sustainability. And you can see here highlighted by the red oval that TPM is clearly identified as part of the delivery strategy and is the core purpose of this level 1 TPM awareness module.
These fellas look pretty happy with themselves.
you could say that none of us as individuals are really special, but as a team, we may well be unique in the sense that we can make a collective and lasting difference. So why is this the case? Well, the common goal and purpose of the TPM system of work and philosophy is aimed at improving the quality of our lives in the workplace, which is perhaps why these fellas look pretty happy with themselves. Well, firstly, let's just remind ourselves of the 5 founding principles of TPM, which mainly came from the early work of Nakajima and Suzuki and their colleagues from the Japan Institute of Planned Maintenance. So let's look at each of them in turn. So the first one is to increase the true effectiveness of the asset, which is often measured using the OEE, or overall equipment effectiveness. An OEE is a measure of the availability multiplied by the performance rate of the equipment, multiplied by the quality rate that the equipment is processing or producing. And common factors that affect OEE are often referred to as the 6 classic equipment losses, being breakdowns, changeovers, and running at reduced speed, minor stoppages, which do not need a maintainer to attend, but require the operator to have to intervene, for example, a jam or a blockage. Scrap, poor yield, rework, not achieving the correct quality parameters. And the 6th loss, which is startup losses that occur after unplanned stoppages or after a changeover or at the beginning of the process. The second principle is about improving existing planned maintenance systems, and this is about focusing on the quality of maintenance. It means that the maintenance engineers decide what mechanical and electrical PMs should be and what they should include, together with the essential spurs needed to support the equipment and each planned procedure. And proper use should be made of the computer maintenance management system, CMMS, in this regard, because as with a healthy body, prevention is better than cure, and the equipment becomes easy to maintain. In this way, the maintenance team can focus, the focus of the maintenance team is not just restricted on maintenance tasks, but also on the relevance of the tasks themselves and finding ways of making the tasks safer, easier, and quicker. So the third principle is when we talk about frontline routine asset care, and this third principle or pillar of TPM is often called autonomous maintenance. And this is when the operator decides together with their maintenance colleague what are the regular basic care routines of look, listen, smell and clean, and whether they should be carried out on a weekly, a daily or a shift-by-shift basis. And this principle is based on a simple but true belief that if you seek the operator's point of view about the best way to operate and maintain the equipment at this basic level, and that knowledge is standardized, they'll stick with it because it was their idea. If, on the other hand, you impose so-called new working practices on them, they're more likely to tick a few boxes on your fancy log sheet, but not actually do the checks. And that's because they have no sense of ownership of the content. Principle 4 is about increasing our generic and specific skill levels. And by carrying out the activities of measuring OEE, improving planned maintenance, and carrying out daily frontline asset care, the operators and the maintainers will also need to increase their skills, not only in terms of the hand operation skills and understanding the functionality of the equipment, but also in things like problem solving, team working, and general IT skills. And doing this will ensure the process and the equipment knowledge will result in a sustained, ongoing interest and care for the equipment in the workplace. And the 5th principle of TPM, which is called early equipment management, is EEM basically is a structured and systematic way of using common sense in relation to new equipment design and installation. And if you're going to invest in new equipment, it's wise to gather existing experience and learning by involving your existing operators and maintainers in the design and the purchase decisions. An EM provides a structured approach to tap into their practical knowledge base at the earliest opportunity, ideally from the concept and high-level design stage, and not when the equipment arrives in the workplace with the control panel not in the best position for the operator and poor access or visibility to check the condition of critical. Well, firstly, so we're going to have a look at a couple of those steps now. So we'll start with the first two steps, which is sources of data and come up with an OEE measure. So this is the thing we're talking about here, which is the gravity belt thickness, for those of you who haven't seen one before. Basically what it's doing is just processing sludge and dewatering it. So the team's challenge here was to think about how can we measure availability. So, they don't have setups and changeovers. It's on the same process all the time, but they do ultimately suffer from breakdowns. And using SCADA, which is the top right picture as a source of data, they're able to look at the number of breakdowns they've had, which caused the belt thickness to fail. And they were able to come up with an availability figure. And as you can see, it's pretty reasonable there, just at 91.67%. Performance was a bit of a challenge for these guys because basically we are trying to calculate the performance of how good we can process sludge at, okay? And interestingly enough, the team found that the actual running speeds of the belts was 8 litres per second against the 15 litres per second, which is the nameplate capacity. And how do we actually measure the amount of sludge that we process? And again, one of the sources of data was to use flow meters and calculate the actual amount of sludge processed. And here you can see from the calculation of the performance, we came up with a figure, a baseline of 48. Quality, again, interestingly here, because the target quality they're trying to achieve here is 6.5% dry solids. And, the point with the percentage dry solids, it's got to be right for the next process, which is the customer in this process, which is the digester. And under will cause issues with the digester in terms of additional heating, and over will cause issues further downstream. So they're measuring the actual percentage dry solids coming off the belt against the target. And under and over is just as bad as each other. So you can see the figures there. 3.25 is a 50% quality, and 9.75, which is over processing, which is also additional poly and all those things, is also over processing. They came out with a baseline figure of 22%. So we're going to have a look at a couple of those steps. Okay, so we're going to move swiftly on to step 4, which is about the criticality assessment. So one of the pieces we use in the training is we use the example of a car, and we get the teams to choose one of the team members' car. And this is the criticality assessment sheet, which is split into all the components and the various categories of safety, availability, performance, quality, etc., etc. What the guys do is they look at these categories and they use a rating scale of a 1, 2, and 3. So, for example, safety says if this component was in poor condition or failed, what would be the impact on safety? Would it be a 1, a 2, or a 3? And when you look at and there's some categories there, and some, they're not all the same, some are different. So, for example, reliability says, is this equipment very reliable? Score a 1. Or does it require frequent attention? Score a 3. Okay, so we're going to move. If you look at the example output, where you score a 3 under safety and a 3 under reliability, okay, that's basically an accident waiting to happen, which is why the driver, the operator, and not the garage, the mechanic, takes responsibility to visually and regularly check the condition of the tyres and the functions of the lights and indicators. And those components scoring a 3 under A, P, and Q, which is obviously OEE, have the biggest potential impact on OEE, so they need to be kept in the optimum condition. And the point behind the criticality assessment, it does these things. It gets the team to work and understand functionality. So in fact, before diving out and doing the condition appraisal and a deep clean in the equipment, without doing cleaning without meaning, which I often refer to, is they understand functionality. They knowing what the critical components are, they can use that as part of the checklist on the condition appraisal, and it helps them focus on future TPM asset care. And it also highlights weaknesses regarding ease of operation, inherent reliability, and ease of maintenance. Okay? But if we look at so here's so this is a photo I showed you before of the poly feed area. What you can see here, the floor is very slippy. The material bund area is damaged, and we've got leakages from the bund area on the wall. The IBC bags from the poly are spilling because the diameter of the pipe is too narrow. And then we look at the restored condition following a refurbishment. That's not just an area that's been tidied up. Okay, that is some weeks since that initial clean has taken place. But what's happened there is we've done a number of things. Okay, we've widened the diameter. The guys have widened the diameter of the pipe. They've repaired the bum walls. They've got the IBC on an incline to improve the yield. Then the blower has been installed, and what the blower has done is it's reduced the noise level. It's acted effectively as a silencer. And the interesting thing is, from here to here, is hearing protection no longer became mandatory as a result of the improved reduction in decibels in that particular area. So just in terms of problem solving, so step 7, we talk about root cause analysis and problem solving. And here we've got some pictures of some problem solving training taking place with the team using the statical simulation, which I'm sure you're familiar with, to help learn a 4-step problem solving process, and then putting that theory into practice. And this is a particular example where they're looking at an issue with the sensor on the gas methane plant, which resulted in significant improvements in gas generation, which is worth a lot of revenue to this business. So I'm going to check it to step 9. So step 9 is about individual and team skill development. So here's just some examples of some of the stuff that the guys in the wastewater treatment plants have done in terms of the skill development. So SNF, the supplier who supplied the poly material, they came in to run a masterclass on the gravity belt thickness and train the team in the ideal parameters for dewatering sludge. Okay, masterclasses run by lots of different OEMs on centrifuge operation. Alpha Laval company came in and did some training on the centrifuge for the ME and I and the operators. General training on digesters. How does what's the chemistry behind the wastewater treatment plant? How does a digester work? What are the ideal conditions for the digester health? And the teams also did quite a lot of green belts through the lean competency system. Going to check it.
We'll now turn our attention to step 10 of the 11-step process, entitled Leadership and Behaviors. So, first of all, a sustainable continuous improvement environment requires the 3 key elements illustrated here as 3 interdependent and hence overlapping circles. The first is to have a robust framework and infrastructure, which is sometimes called a governance system, and this is generally relatively easy to design and implement, hence the 2 ticks. On the left-hand side, we have a second dependence circle called using the right tools and techniques. Again, 2 ticks, because they're generally well proven in the right hands and include tools and techniques like TPM, workplace organization, problem-solving techniques, and so on. In the third dependence circle, we have to generate the right behaviors. And this is where the real challenge lays, and hence the 3 question marks. About 20 years ago, I was told by the installation manager of one of the largest offshore oil platforms in the North Atlantic frontier that management get back the behaviors that they themselves exhibit. So let me share with you what I think he meant by that fairly profound statement and dig deeper to see why this is the case and how we can ensure that that third circle with the question marks needs to be as robust and sustainable as its other two codependent circles. The first thing we perhaps need to do is to consider a new way of working. By understanding the purpose of the work systems and manage the organization as a system with trust and delegation, where we derive measures from the work and not simply arbitrary targets. We will need to modify the traditional management thinking of set, measure, and monitor resources to one where the role of management changes to one where they set the standards and then provide the necessary resources of people, money, and time. And here's the big one: delegate and trust your staff to act on the system with pace and responsiveness when deviations occur from standard, which is supported with robust and high integrity processes. We can illustrate these changes in management style as shown here. In the middle, we have 5 characteristics with 2 comparators either side. On the left side, the traditional, you might say, command and control style of management, compared to the right-hand side of systems thinking. So let's run through the different aspects shown here. Taking the first characteristic of perspective, this is typically from a command and control perspective on the right-hand side of top-down thinking. Systems thinking, which is outside in and bottom up. The performance and standards are set by management in command and control, as opposed to determined by the user in the systems thinking one. The decision-making is separated from the work in command and control, but is actually at the workplace in the sense of systems thinking. And the role of management moves from a command and control, tell and sell, and set and management resources to one of being a coach and mentor to improve the system service. And the fifth one, might say the most important one, employee motivation, moves from the carrot and stick and just do as I say type to pride and ownership. So we can move on from that thinking and perhaps illustrate it as shown here of what is the better style, right? The boss on the right-hand side, the command and control, everyone, but probably inspires fear, finger points blame and uses people and then takes the credit, as opposed to the leader on the right-hand side, who manages with respect for both the individual and the collective team and generates enthusiasm by developing people and giving them the credit and asks their opinion and takes note of what it says and says in effect, let's go and give it a try. The leader who inspires trust to delegate and actively listens and responds accordingly, like any good team coach. These positive leader behavioral attributes start to cascade down through the organization, resulting in what we see here, where the team leader's supervisor's job with the proactive support of that positive leadership process owner style, to do three things: to manage and deliver the operational processes for that particular shift, to manage and progressively develop their own team of people, and to target some form of target-driven improvement, continuous improvement. Now, those first two are usually both given and accepted. And if the third one is regarded as optional, it will not happen. So let's now summarize what this is pointing towards. And we can illustrate it here with three cultural and associated behavioral principles. Ideal results require ideal behaviors. And secondly, purpose and system drive those behaviors. And the third one, principles inform ideal behaviors. Spend a bit of time now looking at the key considerations for delivering a culture of effective partnership between utility asset owners and their operations and maintenance service providers. Our agenda is going to be to, first of all, explore the evolution of outsourcing, to look at the ideal of partnership and its principles, and to develop a progressive reward structure, and finally look at the ingredients for success. So looking at the evolution of outsourcing, it's really gone through three generations. The first generation was characterized by rigid service level agreements and a hands-off relationship, and tended to be essentially adversarial with a them and us attitude and atmosphere. The second generation, with a move away from the pure business driver of pure cost cutting to one improving the effectiveness of the resources and physical assets. And now the emerging third generation, which is partnership-based agreements with a win-win foundation, which is based on building trust, and where a significant part of the reward structure is variable according to predetermined and agreed performance levels. And this was something I developed with British Petroleum in the offshore oil and gas industries a few years ago that I want to share with you, because successful outsourcing relationships often progress from that second one to the third type of generation reward structure shown here. So we can look at it in this way, perhaps. On the right-hand side, you have the traditional generation of one, the first generation rigid and sometimes confrontational. And notice the asset owner is removed from who they called the contractor. And then we went through to the second generation, where there's a bit of alignment with the goals, with the asset owner, who now refers to him as his service provider. A gentle change, where the aligned expectations to improve effectiveness. And what we then need is the integration of effort, so we get integrated operations to generate this third generation of partnership that has common goals. So what we typically find in outsourcing partnerships, some of the issues we come across quite regularly from both the asset owner and the contractor perspective, we typically find these things missing: an ability to develop trust, a long-term commitment, a true culture of win-win and maximizing the benefits to both partners, and medium long-term aligned and deployed strategy. And what we typically observe is rigid service level agreements with no management framework to review performance, because the agreement has been set by purchasing and is not owned by the operations, and leads to adversarial relationships, short-term focus, playing games, politics, And that results in win-lose tactics. There's never a winner. And poor leadership and behaviours at these various levels through that. So if we want to develop sustainable partnerships, there are some underpinning principles. Let's look at these. We're going to move from a cost-centric to a performance-centric, and then to a collaborative, and then a mutual and synergistic approach where the sum of the two partners equals something greater than two. And that means structure and process aligned with leadership and behaviors. And running across the bottom, we're moving from independence to dependence to interdependence. And we want to make sure that connect, or is not a disconnect, but we're going to look at the leadership and behaviors bit here. So the partnership idea, as I say, which I developed with British Petroleum quite a few years back with their service providers, was these 4 dimensions. First of all, maximizing benefit is a contractual arrangement in which the asset owner and service provider agree to work closely together for the increased benefit of both. Then we get the long-term commitment added to that, because it's a long-term commitment between 2 or more organizations for the purpose of achieving specific objectives by maximizing the effectiveness of each party's resources. Then we got the final 2 of trust and shared vision, and that's the challenge. The relationship has got to be based on trust, the dedication to common goals, and an understanding of each other's expectations. So partnership principles demand a sustainable partnership that demands these 3 overlapping circles. The first bit is the right framework and infrastructure, and it's got 2 ticks because that's pretty easy to define and set in place. The second overlapping circle has also got two ticks on the left-hand side, is the use of the right tools and techniques, like TPM that we're exploring here, and other aspects. And the challenge is that third overlapping circle with the 3 question marks to generate the right behaviors. So what we find in typical win-win partnership are these features between asset owner on the left-hand side and service provider, and both parties in the middle. And underpinning all of that is a real appetite and desire to contribute from both parties. So I'm just going to look at the middle bit back there. Is a commitment from management of both sides, a dedication of time and personnel, flexibility to change, and a willingness to share this teamwork approach. And then if we look at what the joint motivations are for that, where, by the way, safety is always our joint #1 priority. In the middle, we're looking for a long-term relationship, both sides, some early wins, job satisfaction, improved quality and safety performance, removed confrontation, access to shared knowledge, because this will allow the asset owner the minimum need to supervise his service provider. They'll be able to, the asset owner focuses on the core business, so to get better control of strategic issues, and yes, reducing overall operating costs. The service provider gets minimum interference, they're left to get on with it, but they're both have the joint motivation to make it work. Integrated teams and systems, continuity of their workload, and a maximum utilization of their resources. So in summary, the essential foundations for a sustainable partnership demands these 9 bullet points. And the first 3 are underlined because visible and proactive leadership, a desire to challenge and improve, and a real interest in performance are, as shown at the bottom, they are the 3 non-optional attributes and behavior of the partnership leaders, because without which the other 6 will be compromised. Consistent use of data, continual checks on understanding, team-based working, focus and enthusiasm, and ability to take action and be accountable, and facilitated and dedicated improvement time. So, the developing a reward structure, this is an example that, as I say, was with BP, where the dollar value is shown there increasing, in this case, over 3 years. But look inside the way in which the fixed part changes from 80% with the partnership performance in the first year, just 20%, to the second year, where the fixed part is 50% and the other 50% is made up of the partnership performance and now the assets performance. And in the third year, it's the reverse of the first year, with the fixed only 20 and the partnership and asset performance making up the other 80%. And it's a progressive increase. That's win-win for both. So some final thoughts on ingredients for success: outsourcing operations and or maintenance. Think of it as performance driven as opposed to cost down only. You need to differentiate between your core business and non-core, both sides. You need to look at what the risks are and hence the countermeasures. And we're going to look at that at the end of this session with the exercise. You must be thorough. If you're setting up a new agreement, go and see your potential partner's track record in other installations. Create a win-win situation from the outset. Be flexible and adaptable, but don't compromise. And take it seriously, because half measures will avail you nothing. You'll recall that at the beginning of our introduction, that we were going to review with you 2 exercises. Now, as we move towards the end of this particular session on day 1, we want to review an exercise with you that you can take away and carry out with your colleagues back in your specific utility. The purpose being to see how today's key learning points might impact your future management of operations and maintenance from the perspective of both the utility asset owner and the service provider. So let's look at the exercise. What we have is, and this is page 1 of 2, what we have is 15 checkpoints. The first 8 are shown on this page here, and the others 9 through to 15 on the second page. So if we go back to the first page, and across the top is a scale of 1 to 5, where 1 is where you're going to position, when you get back to the ranch, back to your utility, with your teams to discuss where you honestly believe you are against these 2 extreme criteria over these 15 points. Do you react to and fix problems as they occur? Or is your work 90% plus preventative based and planned? If you think it's poor and you don't, you would give it a 1. If you think it's fair but not adequate, 3. If it's okay, you'd give it a 4. And by the way, in this exercise, okay is not good enough, because what we want to be is 4, very good, or 5, excellent. I don't intend to take you through all 15 now, because you'll be able to take this away with you and do it at your leisure. But pick up number 5 at random, it doesn't matter. Number 5, we have wrong objectives. We're geared to activities and maintaining the status quo rather than the business needs with clear performance tracking. So you would rate yourself on the scale, which is on the next slide in a minute, we'll look at, on that scale 1 to 5. Or are you the fact that the word maintenance suggests that the status quo is changed to asset performance, that both are focused on improvement with a good reason to exist? And there's the other one. Now let's just pick on one of those. Just please go back there to number 13. There is no control and it's overtime orientated, which means less work gets done during normal hours. Or is the process managed and teams are self-motivated, behaviors are developed to match the role and drive the right behaviors? What a huge difference. Are you 3, 4, 5, or 1? Here's that rating scale for you to use. And there's also on the next slide where you can enter your score there, 1 to 15, to add up your total. If you had a row of 15 fives, you would score 75. If you had a row of ones, you'd score 15. So let's see where you end up your score, and you would put it in this grid. If you end up with an honest score between 15 and 29, it would suggest you have a major opportunity to improvement. If it was 30 to 44, with significant scope. If it's 45 to 59, we're doing well, but can still gain some benefits. If you're in 60 to 74, you'd be world class. If you give a 5 to all 15, you're either disillusioned or or you're the world's best. The point is that the joint partnership agreements we've discussed with you today need to address each of these 15 fundamental reasons for the gaps in your existing maintenance philosophy and strategy. And it recognizes that the partnerships, relationships between operations and maintenance service provider and the asset owner is the key. And the way in which that relationship is integrated and supported is vital if you want true value to your utility business, whether you're the supplier or the asset owner. So just to summarize today's session, now we've come towards the end of it, the key learning points, we've put 4 key learning points here, Andy and I. The first one is that TPM's proven 60-year history is especially relevant today with its emphasis on teamwork, culture, and partnership to maximize the opportunity and the potential of digitalization through Industry 4. The second point is that TPM's founding principles, as described today by Andy and myself, can be adapted, not adopted, but adapted without corrupting them to a wastewater treatment operating environment. And thirdly, you need to start by positioning the TPM system of work within your existing and future intended business delivery strategy. And to help you with that, we've given you a 15-point takeaway of traditional versus world-class exercise, which will facilitate an open, honest debate with your own operations and maintenance delivery partners to begin to see the size of the prize available, which will lead into tomorrow's agenda, where we're going to recap day 1 and to look at this agenda. We're then going to spend quite a bit of our time digging deeper into wastewater utilities case study, and separately the scoping study and key stakeholder buy-in session. And go on to conclude how TPM with the links with the strategic business drivers, and again, a second exercise for you to take away with you. And then we'll have a final wrap-up session with tomorrow's key learning points, final thoughts, and an evaluation of the workshop. Thank you. And thank you for joining us today, and we look forward to seeing you tomorrow.
Okay, guys. We've got minutes for questions, I think. You're muted, I think, Peter.
Okay. Can you hear me now?
I can hear you, Peter. Yeah.
Yeah. Hopefully the delegates can.
Yeah.
If you go to the handout tab, by the way, and press the handout tab, you'll find that exercise there for you to take away, I believe. So do we have some time for any questions?
Yes, Mr. Peter, there's a question from Mr. Sami Ramesh. Autonomous maintenance and routine maintenance are same pillars?
Of what? Sorry?
Autonomous maintenance and routine maintenance are the same pillars. Not really. We deliberately split them into two pillars of preventative maintenance, okay, which is the maintenance, which is predominantly carried out by the maintenance team, and autonomous maintenance, which we don't like to call autonomous maintenance. We tend to call it frontline operator asset care, which is based on the principle that the operator is the best maintainer, the best condition-based monitor ever invented, and therefore using the fact that they operate the machinery, what they can do on picking up signs of deterioration. So we actually look at those as two pillars. We call one preventative maintenance and the other autonomous maintenance or frontline operator asset care.